Hello, algebra students. Today we are starting chapter 8, and 8.1 is simplifying expressions with roots. Please put your name and the date. And let's talk about nth roots. If a equals b to the nth power for a positive integer n, then b is an nth root of a. So instead of saying, it'll make more sense on this next one. If a equals b squared, then b is a square root of a. So see, that's the difference between an nth root and a square root. If a equals b to the third, then b is the cube root of a. So let's look at how this turns out when we have powers. 3 squared is 3 times 3, which is 9, and negative 3 squared is negative 3 times negative 3, which is also 9. And so both 3 and negative 3 are square roots of 9. All right, let's look at how that works with 2 to the 4th. 2 times 2 times 2 times 2. Well, 2 times 2 is 4, and so we have 4 times 4, which is 16. A negative 2 times a negative 2 is positive 4, times negative 2 is negative 8, times negative 2 is positive 16. So 2 and negative 2 are fourth roots of 16. All right, and for 2 to the third, that's 2 times 2 times 2, which is 8. But if we have a negative 2 times a negative 2, that's positive 4, and then times a negative 2 is negative 8. 2 is the cube root of 8, and negative 2 is the cube root of negative 8. All right, so if the n, the exponent, is even, and the a is positive, so the number is positive, there are 2 real nth roots of a. These are called the even roots. The positive even root is called the principal root. All right, so for example, the principal root of 9 is 3. The principal root, the principal square root of 9 is 3. The principal fourth root of 16 is 2. So that's just the positive. The positive even root is called the principal root. If n is a positive integer and a is a real number, there is only one real nth root of a. This is the odd root. For example, 2 to the 5th, because it's odd, right? The 5th is odd. 2 to the 5th is 32, so the 5th root of 32 is 2. And then if it were negative 2 to the 5th, that would give us a negative 32. So negative 2 is the 5th root of negative 32. So if it's odd, there's only one root. Oops, sorry. Because the n was odd. The radical symbol looks like this. Is used to signify roots. The nth root of a is how you read this. So we have an n. Let's see if I can change the color of it. The nth root of a. If n is a positive even integer and a is positive, this denotes the principal root. If n is a positive odd integer, then this denotes the nth root of a. Note if n is any positive integer and we take the nth root of 0, the answer is 0. If n equals 2, we have the square root and we don't have to put a 2 because it's assumed that that is a 2 just for the square root. Let's find the following square roots. Actually, I think I'll have you work in groups on these and then we will go over it. When you're ready, turn your page. Note that even roots of negative numbers are omitted from the definition of nth roots because even powers of real numbers are never negative. For example, if I try to take the square root of negative 9, there's no answer that is a real number. Or the 4th root of negative 81 or the 6th root of negative 64 are not real numbers. So that's because they're even roots of negative numbers are not real. Okay. For this next example, we have the square root of 6 squared. The first thing we do is we do 6 squared, and that's 36. Then we can take the square root, and that equals 6, which is positive. Then we take the square root of negative 6 squared, but negative 6 squared is 36, and the square root of 36 is 6, which is also positive. So in general, if x is real, then the square root of x squared is the absolute value of x. If x is non-negative, then the square root of x squared is just x. And then that means we can extend that to all other even roots, so when n is even, so that the nth root of a to the nth is the absolute value of a if n is an even and positive integer, unless we know that a is non-negative. So let's practice multiplying exponents and see what we get. And this will help us with our next example, knowing how the rules of exponents apply to this. So x to the 5th squared is the same as x to the 5th times x to the 5th. So the exponents multiply in this case, and we get x to the 10th. Therefore, the x to the 10th, the square root of x to the 10th is equal to x to the 5th. We just have to divide the exponent by 2. Right, so x to the 10th, if we divide 10 by 2, we get 5. Here, let's multiply, and we get x to the 21st. So the cube root of x to the 21st is equal to x to the 7th. So we just did 21 divided by 3 to get 7. All right. For perfect squares like x squared, x to the 4th, x to the 6th, x to the 8th, x to the 10th, x to the 12th, and so on, the exponent is even, and it's divisible by 2. For perfect cubes, like x to the 3rd, to the 6th, to the 9th, to the 12th, to the 15th, to the 18th, the exponent is divisible by 3. And for fourth powers, the exponent is divisible by 4. We need absolute value symbols when the result of an even root has an odd exponent. Why? Because we need to make sure that the result is positive. Okay, so any time that we have an even root, we have to use the absolute values. What is the square root of x squared? It's the absolute value of x. And then the square root of x to the 4th is the absolute value of x squared, but because we're squaring it, it's automatically going to be positive no matter what x is. And the absolute value of x to the 6th is the square root of x to the 6th is the absolute value of x to the 3rd, but if we had a negative, it could come out negative, because when we multiply a negative times a negative times a negative, the answer is negative. That's why we need to keep the absolute value bars. But when the n, or the nth root, is an odd number, then we don't need to worry about the absolute value because it could possibly be negative. All right, so our trick here is we're going to divide the exponent by n when taking the nth root. Sorry. All right, so on this one, x to the 3rd, the cube root of x to the 3rd is just x. And the cube root of x to the 6th is just x squared. Let's try that with the 6th root of m to the 30th. Well, 30 divided by 6 is 5. But we don't know if that would turn out as a negative, so we put absolute value bars. Okay, and for D, we have 40 divided by 4 is 10, so that's w to the 10th. Since that is even, we can put it in the absolute value bars. But it ends up being positive no matter what, because if we take it to the 10th power, even if the w was negative, it would still end up being positive, so we don't have to keep the absolute value bars. In your groups, I want you to try the ones that we did not answer, which are these ones. And so get up and work in your groups now. So check your answers and then turn the page to see what the homework will be for tonight. There are some that we did not go over, and so there are some hints in the homework. For number 19, you can go in the book and look at example 8.5, and there's a hint that continues from that. And then for problem 25, you'll need a calculator, and you can see example 8.6 for that one.